Good evening, my YouTube viewers. Crystal here. What I wanted to do this evening is I wanted to talk to you about my solution to the Kaggle Titanic competition question. This is the first question that you get asked when you start entering competitions. I remember when I first saw the competition question, I was completely daunted by it because I didn't know where to begin. But one of the things that they gave us to do was they gave us to submit a data frame that just had all females on it, just to give us some experience submitting data frames. And then we did a tutorial, and they also gave us the answer. I think it was random forest. It was either decision tree or random forest that they gave us the answer for us to submit, just to give us a little bit of experience submitting answers onto Kaggle. And obviously you wanted to keep working on the question, to try to keep working on it and try to get better and better. And so I would investigate. I would look on YouTube videos, and then I would look on the internet to try to find the answer. And finally, I developed my own answer. And so you can see here where I developed my own answer, where I think logistic regression was my own answer that I developed, and one-hot encoding was definitely one answer that I developed. But it's not really one-hot encoding, it's actually get dummies, and we're going to go into that because there's a slight difference between one-hot encoding and get dummies, and I'm going to do a blog post on that, and then I will go into the slight difference between one-hot encoding and get dummies. But they both create columns of binary streams of ones and zeros. And I was thinking, well, since the Titanic question is a classifier question, then perhaps it would do better if we used get dummies and we just had ones and zeros, because if the output is ones and zeros and it goes through a series of decisions to determine whether it's going to be a 1 or a 0, I thought, well, common sense logic says that ones and zeros are going to give you a more accurate answer. But I found out that that was not necessarily the case, because the first time that I did my one-hot encoding, which was really get dummies, I got 74441, and then I went and did the logistic regression, which was higher, 77751, and I tried to do a one-hot encoding with gradient boosting classifier, and I got 67464, and I thought, well, what's going on here? And then I tried to do one hot encoding with random forest classifier, and I got 72009, and I thought something's going wrong here. I did it again with random forest, and I got 71531, and finally I used, really it's get dummies with logistic regression CV, and I got 76794, but that's still not as high as the 78468 that I got when I did the end symbol. But this is my own work. This is just an algorithm that I developed and I made up. I just wanted to see if it would work. So what I'm going to do now is I'm going to take you through this logreg CV, and even though it says one hot encoding, it's not one hot encoding, it's get dummies. But there's not a whole lot of difference between one hot encoding and get dummies. There's just, the difference is, I think one of them makes one less column than the other, but I'll show you how I did it. So first thing we'll do is we'll go over the problem statement of the Titanic competition question from Kaggle. Problem statement is, the sinking of the Titanic is one of the most infamous shipwrecks in history. On April 15, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in the death of 1,502 out of 2,224 passengers and crew. While there was some element of luck involved in surviving, it seems some groups of people were more likely to survive than others. In this challenge, we ask you to build a predictive model that answers the question, what sorts of people were more likely to survive, using passenger data, i.e. name, age, gender, socioeconomic class, etc. And so this was my strategy for solving this mystery, was 1, process the data and clean it, 2, graphically represent the data, 3, break test set up for training purposes, but it was really the training set that we broke up, 4, select model, 5, train and predict on the model, and 6, submit prediction. So that was my strategy to solve this problem. The first thing I did was I loaded the libraries, so you can see what libraries that I loaded. These were just standard libraries that you're going to need with every Python program almost. And then I loaded the files from the Kaggle directory. And so you see we had train, test, and gender submission. The next thing I did was I read the files. I read the trains and the test CSVs. So you can see train here. You can see what it looked like. It had passenger ID, whether they survived, the class, the name, sex, age, SIB spouse, part, ticket, fare, cabin, and embarked. That was on your train file. And here's your information on the train file. So name and sex were objects, as well as cabin and embarked were objects. And everything else was either an integer or a float. So I described the train, so that tells you there were 891 rows, and it was a mean of 446, a standard of 257, minimum of 1. 25% was 223, 50% was 446, 75% was 668, and max was 891. So we looked at the test set. The test set is the same as the train set, except that the test set does not have a survived column, because that's what we have to predict. We have to predict who survived. Then we look at the test info. Test info is very similar to the train info, except there's not a survived column. Then we describe the test file. The description of the test file is similar to the train file. So now what we do is we check for any null values and correct. So in the train set, the age in the cabin and embarked had null values, and in the test file, the age in the cabin had null values. So the next thing we do is we impute the missing values using the imputer. So and we gave an in neighbors of 20. So that means that they looked for files as far away as 20 rows of data away. So it was easy to do that because this is a very small file. I tried it with a much larger file, and I couldn't do it. I had to do like in neighbors of 2 because it took too long to go through it. So sometimes if you have a lot of data, sometimes if you want to use K nearest neighbor imputer, it's going to take a long time to go through the system to impute all that information. So that's one thing that you need to take into consideration, but we didn't have that worry here because it wasn't a lot of rows of data. After we imputed our null characters, we made the age file an integer. We checked to see if there were any null characters in the age file, and no, there were no more null characters in the age file, in the age column. The next thing we did was we checked the fare column, and we imputed the fare column with K nearest neighbor as well. And after we did that, we checked to see if there were any null values in the fair column, and no, there were no null values. And so the cabin and embarked, we just made those mode. Mode is like the most frequent occurrence. And so what it did was it replaced the null values with the most frequent occurrence. And then when we finished that, we checked the train file and the test file to see if there were any null characters. So you can see the train file and the test file after the data has been checked for any null values. Now what we're going to do is we're going to pre-process the data. So what we did was we took the title out of the name using a formula, and we put that title into a column called title. And then what we did was we grouped by the title. We did a group by on the title. And we checked this on the test file. I checked it on the test file, and the reason why is because you have less test files on, you have less titles on the test file than you do the training file. And one of the problems that you have is when you use Get Dummies. Get Dummies will create a column for every category that it has. So in this instance, there were only 9 categories, but on the test file, on the train file, you had something like 18 categories. So you had double the amount of categories in the train file that you did the test file. And then when you get to the model and the point where you're going to predict on the test file, because it has less columns than the train file, then it won't work. And as a result of that, what I had to do was I had to make sure that there were the same amount of columns in the train file as the test file, otherwise it wouldn't work. So that's why I checked the test file instead of the train file. So you can see here are all of the titles that were in the train file, even though I haven't shown them. And so what I had to do was I had to assign numbers to everything to make sure that we had an equal representation of titles in the train file and the test file to make sure that the test file would work when it came time to test our data. So Captain was 1, Colonel was 1, Don was 3, Doctor was 4, John Keir was 3, Lady was 2, Major was 1, Master was 5, Miss was 2, Millie was 2, Mimi was 2, Mr. was 3, Mrs. was 2, Ms. was 2, Reverend was 4, Sir was 3, the Countess was 2, and Donna was 2. And what we did was we mapped that into the title column. And then after we mapped that into the title column, what we did was we did a group by to see where all of these titles fit in. And then what we did after that was we created a Get Dummies. So title train equals PD, Get Dummies, train title train columns is 1 tit, 2 tit, 3 tit, 4 tit, 5 tit. And then we did exactly the same thing with the test file, and then we wanted to see the title train file, and you can see that what it made was it made a table with an index number and then the 5 columns, and these columns had either ones or zeros. So in that table you only had 1 1 in the entire 5 rows of data. So that's what Get Dummies created. And One Hot Encoding creates something a little bit different. It's very similar, but it's not exactly the same. And whenever I do my blog post on this, I'm going to talk about the difference between Get Dummies and One Hot Encoding because it can be quite confusing. The next thing we did was we tested to see if there were any null characters in the title, and no, there were not any null characters in the title. We did a group by on passenger class, and you see that there was 3 classes. You saw a graphical representation of the 3 classes, and then what we did was we checked to see if there were any null characters in the passenger class columns, and no, there were not any null characters. So what we did was we did a Get Dummies on passenger class to make 3 columns for each class. So you had an index column, and then you had your 3 columns, and as you'll notice that on those 3 columns you only had a 1 on one in the every single row of the 3 columns. There could only be 1 in that row. We did the same thing with the train file. We did the same thing with the sex file. We checked to see how many females there were and how many males there were. There were 233 females and 109 males that survived. So you can see more than double the women survived than the men did. We did a graphical representation of that. And then what we did was, again, we did Get Dummies on the sex. So we had 2 columns of 1 sex and 2 sex. And again, on those 2 columns, you could only have one of the columns could have 1 for every row. So it was either a 1 or a 0, because that's what the computer wants to see. The computer wants to see 1s and 0s because the computer operates on binary logic, and it operates on a base 2 number system of it's either 1 or a 0, or it's either on or off. And so if you break it down to a 1 or a 0 or on and off, then you're saving the computer the work because the computer doesn't have to break it down, which is what ultimately the computer has to do to process any information. So we did a chart on the ages, and you can see that the most frequent age was around 30, between 20 and 40. And then what we did was we did a chart on the ages. So you can see we've done a chart on the ages. And then what we did was we created some bins of child, young adult, middle-aged, and pensioner. And we created these bins on the age range. And again, you can see how we did a group by on the age range. And so you can see how many survivors were from each age range. And then what we did was we checked to see if there were any null characters in the train file or the test file, and no, there were not any null characters. That's something that you always have to do, especially when you're creating bins, because it's very easy to come up with some null characters if you don't do the bins correctly. And then so what we had to do was we had to take the age range and we had to use Get Dummies to convert that to 4 columns of data. So again, you can see we've got the 1 index column and then the 4 columns, and you can see that on every row you're going to have a 1 on only one of those 4 columns. The next thing we did was we created a new column, called it Family, and what we did was we added the SIB spouse column to the Parch column. And so we created a new column for that. And then so what we did was we summed the family test and the family train, and you can see that there were 806 in the train family and 351 in the test family. So we did a group by to see how many survivors there were. And then what we did was we did a violin chart, and you can see the people who were single, i.e. 0, had a greater chance of survival. There were more single people than there were couples and families on that boat. And the people who were single on their own, they had a greater chance of survival. And I think the reason why is because they didn't have anybody to think about. They just had to think about themselves. They just had to get on the boat and go. But people who had partners and families, well, they had to think about their partners. Well, they didn't have to, but most of them thought about their partners and their family, and they wanted to make sure that their family was safe before they did anything else. And those were the people who had a higher incident of not surviving. The people who were single and had only themselves to think about, and all they had to do was get themselves on that raft, their survival chances were better than the people who had families. And so you can see right here what I'm saying is there were more single people than anybody else. And as you can see, it's graphically represented that the single people had a higher chance of survival than the married people and the people with families. So what we did here was, again, we used Get Dummies to create columns for the families. And you can see we had one family all the way up to 9 families. If you look at that column, those 9 columns, only one of those columns is going to have a 1 in it, and the rest of them are going to be 0. So on 2 families, that means that there were 2 people in that family. And on one family, it just meant that there were 1 person in that family. So the next thing we did was we tested the FAIR, and we did a violin chart on the FAIR. So you can see that most of the FAIRs were the low end of the spectrum, although some of the FAIRs were quite pricey. We did bins on that, and so we created a range of fares of 0 to 99, 100 to 199, 200 to 299, 300 to 399, and 400 plus. And we checked to see if there were any null characters, and no, there were not any null characters, so that means that we did the bins correctly. And then what we did was we used Get Dummies on the fare range to create 5 columns of the fares. And again, of those 5 columns, only one of those columns is going to have a 1 in it. We checked the embarked. There were three different categories in the embarked range, and you can see that more people left from Southampton than the other 2 locations. And so we used Get Dummies to classify the 3 embarked locations, and I did 1 embark, 2 embark, 3 embark. And we checked to see if there were any null characters, and no, there were not any null characters. And now the next thing we did is this is code here. And what this code is I made a data frame called data train and data test, and I merged all of those data frames together. So I started out with P class, and I merged sex train with it, and I merged age train with it, I merged family train with it, I merged fair train with it, I merged embark train with it, and I merged title train with it. And I did exactly the same thing with the test file, because the train file and the test file have to have the same amount of columns. And so what I did is I wanted to show my work. So this is the data train head, and it only has the first three rows. And so you can see how they're all put together: 1 class, 2 class, 3 class, 1 sex, 2 sex, 1 age, 2 age, 3 age, 4 age, 1 femme, and then it goes all the way to 5 type, 3, and it shows 31 columns in total. Now what I did was I created a heat map, so you can see how the family and the passenger survived relates to all of the other characters in the train file. So now what I've done is I've set up my X and Y values. So Y is your target value, and it is your dependent value, and that's train survived. And X is your data frame, and X test is your data test data frame. So you can see Y, I wanted to see what was in Y, and you can see Y is either 1s or 0s. You wanted to see what was in X. So this is just data train. and you wanted to see what was in X test, and that's just in test train or data test. So now what I've done is I've split the training file for training and testing. So we use train test split. So X train, X validation, Y train, Y validation equals train test split, X, Y, test size equals 10%, random split equals 1. And now what I did was I select my model, and I did this through a series of trial and error because I wasn't getting a very good score. So I was trying to find a model that would give me a good score. So I just fell upon logistic regression CV, which is a type of logistic regression. So model equals CLF equals logistic regression CV, CV equals 5, random state equals 0. That was a mistake on my part. I should not have said equals CLF, but somehow or other it got stuck in there. And best model equals model.fit, X train, Y train, print model.score, X train, Y train. So you'll see that we had an accuracy of 84%. And then what we did is we did something called Stratfield K-fold and cross-validation score and K-fold. We imported those libraries so we could fold it up and test it again and train it again. And we did all that. We had an accuracy, and you can see there's lots of errors, lots of warnings in here. But we did get an accuracy at some point as soon as we get to the end of these warnings. Just keep going. Just keep going to the end of the warnings. An accuracy of 82%. And then what we did was we wanted to test our model on the X validation, and our score was 77% really. So it didn't have a good score to begin with, so I'm doing my best to get a high score, but it didn't have a good score to begin with. And then I'm doing all of my pre-processing, I'm doing everything the way it's supposed to be done, but because the data, the data is not the best data available, we had a lot of missing data, which we had to replace with mode, and we had to impute and other things. The data is not the best data in the world, so we couldn't give the best prediction in the world. What we did was we created a data frame so you can compare your actual values with the predicted values, so you can see how the computer predicted upon it, or how the model predicted on it. And now we made our predictions on the X test, and we sent this X test to a data frame, and you've got a little message saying your submission was successfully saved. And we put the submission into a data frame called mysubmission.csv. And what we did was, you can, which I'm not going to do it because I'm not going to use up all my submissions. But what we did was, if I wanted to, I could press submit, and then I could submit my data to Kaggle, but I've already done that in the past, and I'm not going to do it again. The reason being that we only get 10 submissions a day. And then if you've used your 10 submissions a day, then you can't do any more submissions until the following day. So I don't want to waste my submissions. So I'm not going to submit data that I don't have to submit, because I've already submitted it and shown it to you in this presentation. But what I will do is I will share my notebook, and I will make it public. So if you want to look at my notebook, then it's been made public, and you can go into the Kaggle site and look at my notebook all you like. So that concludes this presentation. If you like my reading, please like, subscribe, and share. And if you like the work I do and you want to leave a donation, I have my email in the description box for a donation. The reason being, I don't have enough subscribers, so I can't monetize, which is why I have to ask for donations. Thank you so much for watching this video, and I look forward to making the next video for you.